Hello year 8s and welcome back to mathematics. In today's lesson we're continuing with our topic of measurement and we're looking at area again. So in the last couple of lessons we looked at the area of a few basic shapes, so rectangles, squares and triangles. In the last lesson in particular we looked at a few more special quadrilaterals, so parallelograms, kites and rhombuses and also trapeziums. In today's lesson we're actually going to be looking at shapes which doesn't have straight lines. So we're going to be looking at the area of circles. So for today's lesson, we want to be able to find the area of circles, and we want to be able to identify the area formula for a circle, apply the area formula for a circle to find area, and find the area of semicircles and quadrants as well. So let's get started. First of all, we need to talk about finding an area formula for a circle. Now, if you remember a couple of lessons ago, we talked about the circumference of a circle, and the circumference, what we talked about was the circumference was the length around the outside of a circle, and we noticed that it had two formulas that we could use. And this involved two measurements on my in my circle. So here, this is one of those measurements. So here, this line here, which goes from the center of my circle to the edge, we call this line, or this measurement, the radius, or r. And so if I want to find the area of a circle, I actually need to use this radius r. And so the area formula for a circle is as follows. A is equal to pi r squared. And so what we do is we take our radius and we square it. Oh, let me write it a little bit neater. There we go. Pi r squared. So we square our radius and then we multiply that with pi. Now, if you have a look here, this formula, there is no other version for my diameter. So what we actually need to do is, if we get given the diameter, one of the things that we need to notice is, so here, I'm going to draw my diameter. If you remember from that lesson on the circumference, the diameter is the length of when we go edge to edge of a circle passing through the center. Now this area formula for a circle, there's only actually one formula here, and we don't actually use diameter in here. So my important note here is, if you get given the diameter, what we need to do is we need to actually find the radius from the diameter. So if we get given the diameter, what we need to do is we need to go, the radius is actually, well, it's just half of my diameter. So it's just going to be my diameter divided by 2. And so here, this is the area formula we're going to be using for this lesson. A is equal to pi r squared. So we need to use pi from our calculator, or if they give us an approximation, that's what we're going to be using. And we multiply that by the radius squared. Okay, so let's have a go at a couple of examples where we need to apply this formula. So just like we had a look at last lesson, actually before we do any of those examples, just like we had a look at last lesson, when we're trying to use an area formula or any formula, what we want to do is firstly identify what shape we have. So here we've got a whole bunch of circles, so we're going to need we don't really need to do this step as much. Then the following step is, then we still want to do the steps. We want to write the correct area formula for the circle. So we want to write for a circle, A is equal to pi r squared. Then we need to find the measurement. So the only measurement that we need to find here for these scenarios is just the radius. And then we substitute it in, and then we calculate the area. So let's have to go to a couple of examples where we need to do this. So finding the area of circles using approximations of pi. So for this first example, we want to find the area of these circles using the given approximate values of pi. Okay, so here in both of these examples, we get given an approximate value of pi. We're not using our calculator for this one to get pi. We're just using what the value they've given me here. So let's have a look at the first one. So here we get given that the value of pi is 22/7, and we have this circle over here. Now if you have a look at this circle, we've got this measurement of 7 meters, and that is my radius. So that's perfect for me. I can just use my formula. So here, I'm just going to write here, area is equal to pi r squared. That's me just writing down my formula for a circle. And so here, I just need to substitute my values in. Now they've also told me that pi is 22/7, so I'm going to write down 22/7 times 7 squared. And just like we did before, when we're writing this, we're finding the area. So here the measurement is in meters, so the answer is going to be in meters squared because it's an area. Okay, so I've got 22/7 times 7 squared. If you're not sure how to calculate this, there's a few ways that you can do this. If you're not sure how to do it, you can chuck this straight into a calculator. But another trick that I can use here is, I notice that there's 7 here, and I've got 7 squared, so I can just cancel one of these out. And so I've got 7 times 22, which I believe gives me 154 meters squared. So in the case you're not sure, you can always grab out your calculator and just go 22 over 7 times 7 squared, and so we get 154 meters. Okay, excellent. There we go. That's our first example. So here with our area of a circle, we're using this formula A is equal to pi r squared. Let's have a look at the next one. Here for this circle, we're given the approximation of pi is equal to 3.14, and we've got a circle here, and we've got this measurement of 10 centimeters. Now, if you have a look at the diagram, we are going from center to the edge. So that is my radius. So that is perfect for what I need here. So let's just write down the formula. A is equal to pi r squared. I'm going to substitute my values in here. So I've got pi was 3.14. We're using that approximation times 10 squared. Once again, you can put this in the calculator if you're not sure how to do it. I'm going to go through a trick in a moment. Here, because I've got a measurement in centimeters, this is going to be in centimeters squared. Now, if you remember when we were converting between units of area, when you're multiplying by a power of 10 squared, you just count up the zeros and double it. So here 10 squared will be 100, so that's 2 zeros. And all I need to do is just move the decimal point to the right twice. And so my final answer is going to be 314 centimeters squared. You can always check that with a calculator. 3.14 times 10 squared, and that gives me 314 centimeters squared for this example. Okay, so that's how we find this area of a circle. All we're doing is we're substituting our radius into this formula, pi r squared. Okay, so let's have a go at the next example. Now, the next example, we actually need to use our calculator to use the value of pi. And if you remember from our lesson on the circumference, there's a button that we can actually use on our calculator to help me just give me the exact value of pi. So here, use the calculator to find the area of the circle, correct to 2 decimal places. So it's a circle. We're going to write down the area formula. A is equal to pi r squared. And then what the formula tells me is I need to find the value of r. And so here in my circle, I've got my center to the edge. That's 2 centimeters. That is my radius. And so my radius is going to be 2. I'm going to go, this is equal to pi times 2 squared. Okay, now once again, we need to check the measurement. So here the measurement is in centimeters. So my answer is going to be in centimeters squared. I'm going to write here cm squared. Okay, let's check this in the calculator. Now, when you're tracking this in the calculator, we need to use the value of pi. So here they ask us to use the get the value of pi from the calculator. So here, the way that we do this, shift times 10 to the power 10 to the power x. So we get this pi times 2 squared, and we get 12.566. Now we want this to 2 decimal places. So it's going to be 12.57 if we round there. So 12.57 centimeters squared. Okay, so that's how we find the area of a circle. If we want to find the area of a circle, what we need to do is use this area formula of pi r squared. Pi times the radius squared. Okay, so that's the first part of this lesson. We're calculating the area of circles. So this is when we get the whole circle. Now, the second part of today's lesson is looking at finding the area of quadrants and semicircles. Now here, I've got 2 diagrams, and I know they're badly drawn, but that's fine. And these are what a quadrant and a semicircle is. Now, the first one is a semicircle. Now, if you notice, the semicircle is just going to be half of a full circle. So it's just half of a full circle. So if we want to find the area of a semicircle, all we need to do is just take half of the area of a circle. So it's going to be half times the area of my circle, which is just half times pi r squared. So we want to find the area of a semicircle. So this is my semicircle. If I want to find the area of my semicircle, I just need to find half of the completed circle. Half of the area of the completed circle. The second shape is a quadrant. Now, a quadrant is so this one's a quadrant. Now, if you have a look, quadrant. I couldn't spell that. Quadrant. Now, if you have a look at the quadrant, actually, this is what you would get if you took a quarter of a circle. So here, if we split up a circle into quarters, one quadrant is just going to be 1/4 of a circle. And so here, if I want to find the area of my quadrant, that's just going to be 1/4 of my circle. And so that's just going to be 1 over 4 times pi r squared. And so when we're just trying to find the area of a semicircle or quadrant, what we can do is just find the area of the whole circle or the whole for the particular semicircle or quadrant, and then just multiply that by a half for a semicircle or a quarter but for a quadrant. So let's have a look at a few examples of this. So finding the area of semicircles and quadrants. Find the area of this quadrant and semicircle using your calculator correct to 2 decimal places. So we want to use our calculators for these following parts. So here, let's have a look at this first example. So here we have a quadrant. So that's a quarter of a circle. So what I'm going to do is I'm going to write area of my quadrant for this first example is just going to be 1 over 4 times pi r squared. So that's just a quarter of my full circle. A quarter of my full circle. Now here we just still need to find our measurement. So here we need to find the radius of that full circle. And so here it's going to be a quarter times pi times, well, if you look at this measurement, that's the center of my circle and it goes out to the edge. So this point here is the center of my circle and it goes out towards the edge of my circle. And so my radius is going to be 3 squared. 3 meters squared. And so here I just need to add on the unit at the end, meters squared. We can chuck this in a calculator. So we've got a quarter, 1 over 4 times pi times 3 squared. And so we get 7.068. And we need 2 decimal places. This just becomes 7.07. So this is 7.07 meters squared. And so when we're trying to find the area of a semicircle or quadrant, we just want to find the area of the whole circle. So that's what we did over here with pi times 3 squared. And then we find out for here, because it's a quadrant, we find a quarter of that amount. Okay, let's have a look at the next example. Now here we've got a semicircle. So the area formula for a semicircle is just half of my circle. So half of pi r squared. So here, just like we did before, we just want to find half of the area of my circle, and so we need to find the length of the radius. Now, if you have a look at the diagram here, well, they tell us that this length here, this length is 5 kilometers. If you have a look, the center of my circle is here, and so this actually isn't my radius. This is the diameter. And so what we need to do is, if we want to find the radius, we need to actually halve our diameter. So here, I'm just going to write on the side, r is just equal to my diameter halved. I'm just going to halve my diameter. And so here, I've got 5 kilometers. So what I'm going to do is I'm going to go 5 divided by 2, and that's going to give me 2.5. And so my radius here for this circle semicircle is going to be 2.5 kilometers. So here, the length from here to here is going to be 2.5 kilometers. So you need to be very careful when you're trying to find the area of a circle. We actually need the radius. We don't want the diameter. And so here I actually need to find my radius by just halving the diameter. So now that I've done that, I can substitute this all into my formula. So here I've got half times pi times 2.5 squared. And here, because the measurement's in kilometers, it's going to be in kilometers squared. Okay, and so here I can check this in my calculator. I've got 1 over 2 times pi times 2.5 squared. So we get 9.82 kilometers squared. So there we go. Okay. So let's just quickly recap what we talked about in today's lesson. In today's lesson, we looked at finding the area of a circle. So when we try to find the area of a circle, we need to use this formula of pi r squared. So we take pi and we multiply by the square of the radius. The important note here is if we get given a diameter, we can't actually use the diameter directly. We need to convert that diameter into a radius by we need to change that diameter and find the radius from the diameter by taking half of the diameter. So here, d over 2. We went through a few examples of this, and just like we did in the last lesson when we looked at finding the area of different shapes, we first want to just write down the formula for that shape. And so here we just want to write down pi r squared, then we substitute our values in. So if we get given an approximation of pi, we use the approximation they give us, and also we want to find the radius that we need to substitute in. And then we can calculate that. We can chuck that into a calculator if we want to make it easier, or in a few cases, there's a few easier examples. When you get asked to use the exact value of pi, so using your calculator, you do need to use your calculator for that. Then from there, we also looked at finding the area of quadrants and semicircles, and we noticed that a semicircle was just half of a circle, and so we just took our area of our circle and we just halved it. And for our quadrant, we saw that that was a quarter of a circle, and so what we did was we take our area of our circle and we took a quarter of it. So that's it for today's lesson, Year 8. I hope that was helpful, and as always, I hope you guys are staying safe wherever you are, and I'll see you in the next video.